Okay, this is video number 51, and it refers to video number 51. I'm going to solve both these problems just as I left them yesterday, and then I'm going to talk about conversion, and that would include maybe another video if I don't finish what I need to teach you, and I'll leave you a problem to explore for tomorrow. Okay. So I was trying to teach you yesterday that all equilateral triangles are similar. That means they differ by a scale factor only, and that if you know the side of one of the triangle, then you can not have to do any math to figure out the area. But since we talk about square units, well, then of course the scale factor has to be squared as well. So let's do this one here, and we'll quickly dispatch the first one here, which is just the equilateral triangle plus the trapezoid. We've been kind of used to that. And I gave it a height of 1 and a base of 2, and of course this is 6 and this is 6. And now I'm going to show you how easy it is, so I don't have to draw the perpendicular bisector. I don't have to go through all that stuff, since the when r equals 1, then the area is pi. Excuse me, not pi. Radical 3 over 4, and I'm putting a 1 here to make that clear to you. Then when the radius is 6, then instead of the 1 I write 6 squared, making it like that, 6 squared times radical 3 over 4, which equals of course 36 over 4 radical 3, which equals area now equals 9 radical 3. So it was that easy to do the math. And again, you could work it out the way I've been working it out if you choose, and you'll get the same exact answer. So instead of the 1 here that I had when the radius was 1, when the radius is 6, instead of the 1 I just place the 6. 6 is the perfect square of 6 is 36. 36 divided by 4 is 9. Done. Okay? And so I'll just write it over here so you can clearly see it. And now all I have to do is basically a 6th grade problem, but a problem that you'll have to deal with on your upcoming test is that, again, I take advantage of symmetry. We're assuming all these objects are similar, so that makes this 2, that makes this 2, and since the height is 1, of course, it's not drawn to scale, and this is the right angle, this is the right angle. There are 2 of them. If we need to do the perimeter, we'll do the perimeter anyway since it's so easy. I have 2 squared, that's this side, plus 1 squared, a number I just arbitrarily gave it, and that equals the height squared. And then that's 4 plus 1 equals 5. So the height squared, the height, since we're taking the radical of each side, the square root of each side, is radical 5. So now I'm in great shape to do the problem. The trapezoid is radical 5 times 6 plus 2 divided by 2. So that's 8 divided by 2. So this is 4 radical 5. Okay? So we add them together, and the volume of this, the area of this is 9 radical 3 plus 4 radical 5. Random numbers, but the point being that that you can easily do the work. It only took me a couple seconds. Imagine if I were on my own, I'd be done in a couple of seconds. So you can imagine how easy the next one is. I'll go over to the other side and do it. There you see. Oh, by the way, the perimeter is, of course, this is radical 5. This is radical 5. So P would equal 6 plus 6 plus 2 plus 2 radical 5, and that would equal 14 plus 2 radical 5. Can you still see it? Yes, you can. And when I factor it out, which again, like I promised we'd talk about further, I come up with 7 plus 5 radical 5 multiplied by 2. And I mentioned that either answer would be okay. Again, we'll talk about factoring down the road. So there we go. And the second part will be even easier to do. Again, it's a compound figure. It's irregular pentagon. So if r equals 1 implies 1 over radical 3 divided by 4. Then when r equals 7, that implies 7 squared radical 3 over 4. So the area on this guy on the top here is 49 radical 3 over 4. These numbers are co-prime, 7 times 7 and 4. So there's my area. I'll just quickly write that out. Okay, and now I have to figure out again the area of the trapezoid. So since this is 2 and this over here does the same thing, we have 7 on the bottom. 7 to do the math to come out right would be, let's see, 2, and over here would be 2, and this would be 3. There's our symmetry, so I get 2 squared. There's your right triangle all over again, plus 2 squared. Oh, it's really an isosceles triangle if you think about it, and that's 4 plus 4 equals h squared, and again we put the hat on both sides, so h equals radical 8, which is equivalent to 2 radical 2. Math that's been discussed. So now we figure out over here the area of this particular trapezoid, which is 2 radical 2 times 7 plus 3 divided by 2. Any way you want to do it, you can do it. And so this would be 10 radical 2. Okay? So the answer, if I'll write it right at the bottom here, is not that it's a particularly profound answer. It's 49 radical 3 over 4 plus, what do we have over here for the trapezoid? We had plus 10 radical 2. And if I wanted to put it all together like we might do in a more complicated math problem, we'd have 49 radical 3 plus 40 radical 2, and the whole thing being divided by 4. And again, 6th grade math all over again. I'm just multiplying the top and the bottom by 4. And this would be considered a proper answer, but this would get the job done as well. Okay? All right. So we're 8 minutes into this, and what I'll do is I'll send you this, and I'll make video 52 a discussion of conversion, kind of lesson I've kind of prepared for you. So we'll do it that way. And I just put these 2 random problems out. I did it really fast, didn't really plan it, because now I'm just trying to say, you plop any equilateral triangle onto a trapezoid so that they fit, making the compound figure. The work is done very quickly. Okay? All right. So let's leave that for now, and then we'll talk about